Okay, so today we're going to be going through the HSC Standard 2 2020 paper. Now we're not going to get through all of the questions in this video, but I'll try and get through as many as I can. And then I'll try and have another video out. Won't be able to finish all of the questions, but I'll try and pick out a couple of the trickier questions and just go through those. So this is just going to be the first half dozen questions or so. Hopefully, if you're having a bit of difficulty, don't know how to approach some of these, I'll walk through how to do some of the questions, and hopefully that information is applicable for you in the rest of your practice exams. Okay, so first question up is question 16. We're just going to be starting at the long response questions. Hopefully you should be able to do the multiple choice by yourself, but this should give you a bit more description on how to do things if we go through the long response answers. So question 16 is just a simple trigonometry question. So it's find the value of theta to the nearest degree. Right, so let's just look up. This is the opposite. We can name our sides. Adjacent is over here. And then obviously this is the hypotenuse of the triangle. So the tan function is just opposite over adjacent, which gives us tan of theta is just equal to 8 over 10. And then if we take the inverse of that, theta is equal to the inverse of tan of 8/10, which gives us theta is equal to 38.65 degrees. And of course, we want to round to the nearest degree, which gives us 39 degrees. And that's part A. Part B asks us to find the exact value of x. Now, this is actually pretty easy. It's just Pythagoras' theorem, right? 8 squared plus 10 squared is equal to x squared. So x is equal to the square root of 8 squared plus 10 squared, which is 12.806. And if you round to the nearest decimal place, 12.8. All right, question 17. Alia wishes to estimate the number of trees on a square block of land measuring 1,000 meters by 1,000 meters. She counts the number of trees on a 5 by 5 meter section of the block and finds there are 8 trees. Based on this, estimate the number of trees on the entire square block of land. All right, so here we have a block of land with 8 trees on it. It's 5 by 5 meters. So the area of this is simply 5 meters times 5 meters, which gives us 25 meters squared. And remember that squared because it's important. So the number of trees are 8. So we have 8 trees per 25 meters squared, which gives us 0.32 trees per meter squared, right? So now let's draw up the 1,000 by 1,000 meter block. Taking our value from before, 0.32 trees per meter squared. Our total area is 1,000 meters times 1,000 meters, which is 1 million meters squared, or 1,000 square meter, 1 million square meters. Now the number of trees on this block is simply the total area times the trees per unit area. So in this case, it's 1 million meters squared times the 0.32 trees per meter squared. So those units simply cancel out, right? Meters squared on the top, meters squared on the bottom, they cancel out. I'm going to rewrite this in scientific notation. You can plug this straight into a calculator, but I thought we'd just do a little bit of practice on scientific notation. So 1 million is 1 times 10 to the 6th, and then we've got 0.32, right? So this, we can do 3.2 times 10 to the negative 1, or as I've written it here, 32 times 10 to the negative 2. Right, so if we multiply these together, you just multiply the numbers at the front. So 1 times 32 is simply equal to 32. And then we add the exponents for the 10 to the power of. So 10 to the power of 6 minus 2. 6 minus 2 is 4. So we get 32 times 10 to the power of 4. So you just put 4 zeros on the end of that, right? Which gives us 320,000. And so that's the number of trees on the block, 320,000. Okay, so question 18. Here we have a network question. So it simply asks us to draw the minimum spanning tree for this network in the space below. Okay, so one thing to cover just before we start this is you may get a completely different minimum spanning tree because hopefully, as you should remember, minimum spanning trees are not unique to the structure. However, their length should be the same. So if I get one length for this, you should get the exact same length if you've done it correctly. However, you may get a completely different structure for the minimum spanning tree. It depends on where you start in the structure and a couple of the choices that you make along the way. But I'll try and describe those as we get to them. So let's just transfer this over to the paper like this, and then, of course, find the minimum spanning tree. So I'm going to start over here on the left with A as my first node. So first step is just to select A. Second step, there's only one node that we can actually select, so it's B, right? That choice is made for us. And now for the third step, there are two choices for how to connect an unconnected node to the tree. And that's what you should think about this as doing. We're trying to find a node that could be connected to the tree, and then each step connect one of those nodes to the tree. But we want to make sure at every step it is the cheapest node to connect to the tree. So here, as we see, we have two possible nodes. We have C and we have E. Both have a cost of 3, and so it doesn't actually matter which one we choose. And this is one of those places where you can get a different tree if you choose one direction versus if you choose another direction. But you should get to the same answer for the value of the length of the minimum spanning tree. So here we're simply going to select C, and then move on to step 4. Now there are 4 choices for us to pick. There is E, D, F, and G. So what we're actually going to do is draw up a little table here to help us see what all of the different lengths are. You can see E has a value of 3, D also has a value of 3, F has a value of 2, and G has a value of 5. So obviously the node to select here is F with its value of 2, and that becomes our next step in the network. Step 5, we have 4 options. You can see here, and I've put them in the table again. Now some of these have 2 values in their cost, and this is because they can be reached in one of 2 ways. So if we take node D, for example, we can reach that from node C with a cost of 3, or we can reach it from node F with a value of 2, right? So that's why there are 2 numbers in the bottom of that table. Here you can see I've highlighted both D and G have a cost of 2. Of course, H also has a cost of 2. I simply made a mistake on this slide, so forgive me there. But we'll select D as our node and move on. Again, it doesn't matter. We could select D, we could select H, or we could select G, so long as we select the path or the edge of cost 2. It doesn't matter which node we select. So now move on to step 6. We have 3 nodes to choose from, E, F, and G. All of these have minimum cost 2, so long as we select them from the correct path. We're going to select node E here. Just for convenience, add that one to the tree. Move on to step 7. We have 2 nodes now to select from, node G and node H. Both have a value of 2, but we'll select node G. And then finally, we have only one choice left for our final node, which is node H. I've said here we can reach in one of 2 ways. You can actually reach in one of 3 ways from node D, node F, or node G. But obviously, node G has cost 1, and so that's the node that we use to connect to the network. So now if you add up all of these lengths, so the length from A to B is 2, B to C is 3, C to F is 2, and so on. If you just add all these numbers up, you should get 14, which is the length of the minimum spanning tree. Now moving on to part B of this, so just bringing up the network again. What part B asks us to do is add a new node to the network. So it connects at node A with a value of 12 and at node C with a value of 10. So obviously if we still want to find the minimum spanning tree, we choose length 10, which means that our new spanning tree is the length of our previous spanning tree, 14, plus 10, which equals 24, which is the length of the new spanning tree with the added vertex, right? Okay, and on to question 19. So there is a little bit more of a diagram for this question that shows the paddock it refers to that I have unfortunately cut off for this slide. So if you're following along with the paper, just jump on to question 19 and you'll see it, but it's not strictly necessary. So the information it gives us is a total of 900 meters of fencing is to be used for a paddock. The equation that it gives us is 3x plus 2y equals 900. So 3 times the x value plus 2 times the y value must equal 900 meters of fencing. The area that this encloses, the area A in square meters of the rectangular paddock, is given by A equals 450 times x minus 1.5 times x squared. And the graph of this is shown below. So here we are. If the area of the paddock is 30,000 meters squared, what is the largest possible value of x? Okay, so let A equal 30,000 meters squared, find the largest possible value of x. So by inspecting the graph, putting some lines on, we see the line from 30,000 meters intercepts the parabola at 2 points. You should see, because this is a parabola, we get, in certain circumstances, we get 2 solutions, which you can obviously see. And so the intercepts for those 2 solutions are x equals 100 and x equals 200. That can be gained just by inspection of the graph, and everything's neatly lined up, so you should be able to do this just with your ruler and the paper. Now, part B of this question asks us to find the values x and y so that the area of the paddock is as large as possible. Now, this is a little bit more tricky. You could inspect from the graph, but I suspect you might not be as accurate as you would need to be for this answer. So what I've shown here is the axis of symmetry, right? And you should remember that parabolas have an axis of symmetry. And you can see that as we move from the left of the graph to the right, the value is still increasing, but it's increasing at a decreasing rate, right? It's getting slower and slower until eventually it turns around and starts coming back down. So obviously the highest point that it can reach is the point at that axis of symmetry, right? That would give us the highest value. If this parabola was inverted, so it was a positive parabola, well then it would be the lowest point, but because it's a negative parabola, it's the highest point. So how do we find the value of x at this axis of symmetry? Well, you can inspect the graph again, and I suspect you'd probably be able to make quite a good guess of that. But we're given the values x equals 100 and x equals 200 for the 2 points, and the average of these 2 points, because they correspond to the same y value, gives us the axis of symmetry. So x equals 100, x equals 200, plus them together, but 300 divided by 2, 150, which gives us the axis of symmetry occurs at x equals 150. So now we take the equation that relates x and y together, which is this 3x plus 2y equals 900. And we know that the maximum area must occur when x equals 150, so we can simply plug in that value, x equals 150, into this equation, which gives us 2y equals 450, and 450 divided by 2 gives us y equals 225. Right, you can just do that on a calculator. It's pretty easy. And so here are the numbers that we need to save. Part C of this question is the simplest. It just asks, using the values from part B, find the largest area of the paddock, right? Well, the area is literally just the x times the y, which is 150 for our x value and 225 for our y value. Times those two together, you'll get 33,750. You should actually have meters squared on the end there. I apologize for not having it. But yes, the area is 33,750 meters squared. All right, and on to question 20. Question 20 is a financial maths question. It says the table shows the income tax rates for the 2019 to 2020 financial year. For the 2019 to 2020 financial year, Wally had a taxable income of $122,680. During the year, he paid $3,000 per month in pay-as-you-go tax. Calculate Wally's tax refund, ignoring the Medicare levy. All right, so let's first calculate the pay-as-you-go tax that he paid. So he pays $3,000 per month over a 12-month period from 2019 to 2020. So $3,000 times 12 months equals $36,000. Now he has an income of $122,680. So what we need to do is find out which tax bracket he falls into. And it's this one, right? So he earns between $90,000 and $180,000. And so he falls into this tax bracket, which means straight up he pays $20,000 $797 plus 37 cents for every dollar he earns over $90,000. So the 20,797 is simply all the tax he would have paid for all of the previous tax brackets stacked up. It's just all of the math done for you. So it's just lump sum payment of this plus 37 cents for every dollar over 90,000. So we take down the $20,797 and then we plus 0.37, which is 37 cents. All right, 1 cent is 1/100th of a dollar. So 0.37 times 122,680 minus 90,000. So this gives us a total tax of $20,797 plus $12,091.60 equals $32,888.60. Right? So now his tax refund is simply the difference between what he has paid in tax and what he was required to pay. So by his tax bracket, we know he's required to pay $32,000. He did pay $36,000, so we simply take the difference between these two numbers. 36,000 minus $32,888.60 gives us $3,111.40. Question 21, another financial maths question. The inflation rate over the year from January 2019 to January 2020 was 2%. The cost of a school jumper in January 2020 was $122. Calculate the cost of the jumper in 2019, assuming that the only change in the cost of the jumper was due to inflation. All right, so first thing we want to do is turn this into an equation. So allow x to equal the cost of the jumper in 2019, and let y equal the cost of the jumper in 2020, which we know to be $122. Right, so y is equal to x, the original cost of the jumper, plus the 2% inflation rate, right? So it's x plus 0.02 times x, which is its initial value, plus the 2% that it has grown due to inflation. Now this gives us, plugging in our value for y, 122 is equal to x times 1.02, right? Factorizing out the x gives us 1 and 0.02, so 1.02. Now we simply divide this value across, which gives us x is equal to $122 divided by 1.02, which is $119, 0.607, which of course we want to round to just 2 decimal points because we're dealing with finances, which gives us $119.61. Question 22, continuing with the finance theme. NISA has a credit card on which interest at 17% per annum compounded daily is charged on the amount owing. At the beginning of the month, NISA owes $500 on her credit card. She makes no other purchases using the credit card, but 15 days later, she pays $250. Assuming that interest is charged for the 15 days, calculate the amount owing on the credit card immediately after the $250 payment is made. All right. So the initial amount that she has on her credit card is $500. Now, we know that the interest is 17% per annum, but because we're compounding the interest daily, we have to get the percent interest that is charged per day, which is simply converting 17% per year to some percent per day, which we do simply by dividing 17 by 365, which gives us 0.047%, which as an actual value is 0.00047, right? Simply because converting to a percentage, you times by 100, converting back from a percentage, you divide by 100. So now we go to the this compounding interest formula, which is something you should all know. It's on your HSC formula sheet. FV is future value is equal to PV, which is present value. Inside the brackets is 1 plus the interest rate, and then N is the number of times that the period is compounded, right? So $500 is our present value, 1 plus 0.00047, which is our 0.047% interest per day, to the power of 15, which is our 15 compounding periods. This gives us a total value of $503.50. Now this is on the 15th day that the account balance will be $503.50. Now, on that 15th day, immediately after the 15th day, she pays $250. So we subtract that out, which gives us $503.50 minus $250, $253.50. And that's it. Okay, so that is all I have time for at the moment. I'm going to run through this paper and try and pick out a couple of more questions. Just obviously, I can't get through every question doing all the illustrations and video editing and stuff. I'm still quite new to, so it takes me a while. But I'll find a couple of the more difficult questions, try and get a broad spread of, some measurements, some graphs, some other stuff, and just try and get a wide variety of questions through. And I'll try and put another video out with that, and hopefully that should give you just, the basic bones to attack whatever questions or wide variety of questions that you come across. Also, I do tutoring over Zoom, so you should see my contact information and card and stuff up on screen now. If you or anyone else or if you're a teacher or anything, anyone's struggling year 11 or 12 in any one of the maths categories, feel free to contact me and check out if I have any slots. Anyway, I look forward to seeing you in the next one. Thank you. Bye.